Well, good day, everybody. And today we are going to be looking at the exercises. I've already covered just how to go through this section, right? And I am solely going to be looking at the exercises, or rather the solutions to the exercises that I gave you on this section. Now, let's quickly have a look at it. Right, so I've already done A, B, and C, right, in our previous video, or the video that I produced for this section. Now let's look at how to go about D. So I think that you probably got D correctly if you tried it. Okay, so we had Z is equals to 5 plus 2I. And remember, how do we work out the modulus in this case? Right, so modulus would simply be, remember, that's going to be the square root of our x squared plus y squared values. So that's the real as well as the complex part of our, or rather the imaginary part of our complex number. So we're going to have 5 squared plus 2 squared. 5 squared, that's 25. 4 squared, 2 squared, that's 4. So we end up with the square root of 29. Okay, right. So in this case, I'm going to leave it in that form, right? And now let's go and look for the argument. So we say the argument of Z. We said you can say arc10, that's y over x. So our y value is 2 divided by our x value, which is 5. So shift the 10 of 2 divided by 5. I made a mistake there. Shift 10 of 2 divided by 5. There we go. We get 21.8. So it's 21.8 degrees. Now, ladies and gents, that is how we're going to go about D. Right, quickly let's go for E. So we had to do a little bit of some gymnastics when it comes to E, right? So we had to go about, we had to actually try and simplify it first before we can actually solve the thing. So let's do that. So for E, we have Z is 3 plus 2I, and this is all squared. Now what do we do? Right, we know that when we square a bracket, now I already said to you, there's an easier way of doing it. So we just square the first term, that's 3 squared, that's 9. And then you square the last term, that's 2I squared. Right, that would give you 4I squared. But for the middle term, what do we do? This will be 3 multiplied by 2, right? So 3 times 2I gives us 6I multiplied by 2. So that gives us 12I. And this is plus 4I squared. And let's simplify, ladies and gents. So that's 9 plus 12I. And we remember that I squared gives us -1. If you don't know that, please go back to our videos on multiplication of complex numbers, right? So that will actually tell you how to, why that is the case. So that will be 9. And 4 times -1 gives us -4. So 9 minus 4 will give us 5 plus 12I. Now, we know what is our x value. Our x value is 5, right? That's the real part. And we know what is our y value, which is the imaginary part. So we can now calculate what is our modulus. So the modulus of Z would be the square root of x squared plus y squared. So that would be our x squared value is 5 plus 12 squared. We've got 25 plus 1. Okay, we forgot the square root there. Right, that's 144. All right, ladies and gents, that gives us 169. All right, that should be 16, I think. So the square root of 25 plus 144, or 13 actually, 13. So that will give us 13 as our modulus, right? So argument, I did say to you, we can use something different. Let's take the cosine. We haven't used cosine, right? So you'll say the arc cosine of. Now remember, when we talk about the cosine of it, okay, what are we going to do? We are going to actually just say that's x over r. So what is our x value? X value is 5. So this is going to be 5 divided by 13. Okay. Oops. Just did something there. All right. So that's 5 over 13. So shift the cosine of 5 divided by 13. And we get 67.4. All right. So that is the argument of z. By the way, ladies and gents, nothing wrong if you decided to use 10. Okay. That would be the arc 10. But remember, when it comes to 10, 10 is y over x. So our y value is 12. Our x value is 5. So we should get the same answer. Shift the 10 of, oops, not sure what's happening. 12 divided by 5. And we get exactly that same answer, which is 67.4 degrees. Right, so that is really how we're going to go about it. Right, and ladies and gents, the final one. Right, F, how do we do that? You remember when we spoke about, in fact, let me write it down first. So we've got 3 plus 2i divided by 2 plus I. Now, what do? We are looking at the division in this case, right? Division of complex numbers. And what did we say about division of complex numbers? We are going to introduce the conjugate. So if you have not watched that, please just watch our video on the conjugate. And what do we multiply by the conjugate? The denominator. So what is the conjugate of our denominator? We always change the sign of our complex number. That's 2 minus I. But what I do at the bottom, I do at the top, so that it does not change the number. So we are essentially multiplying by 1, right? Which is a multiplicative identity. So let's multiply. So 3 times 2, this gives me 6. 3 times negative I, that's minus 3i. That's 2i multiplied by 2. That gives me 4i. And finally, that gives me 2i times negative I. That's going to be negative 2i squared. And this is divided by, when I look at the denominator, that's going to be 2 plus I multiplied by 2 minus I. That's going to be the difference of squares, right? So that will give me 4 minus I squared. Right, and let's simplify this further. So that's 6 minus, now if you look at this, I've got minus 3i plus 4i, which will give me plus I, minus 2 times I squared is negative 1, okay? and that's divided by 4 minus I squared, as I said, is -1, and so that becomes 6 plus 2, which gives us 8 plus I, okay, divided by, if you notice there, I've got 4 minus a -1, so that's 4 plus 1, that gives us 5. Okay, so we've got a fraction for the first time. So z is equal to 8 over 5 plus 1 over 5i. All right, so now let's express that for our modulus. How are we going to work that out? So z will be the square root of x squared plus y squared. Okay, and x is the real part of our complex number, so that's 8 over 5 squared plus 1 over 5 squared. Right, let's write that down nicely. I'm not sure why it keeps doing that. Okay, maybe let me just bring my calculator this side. All right, yeah, maybe we'll have less issues there. So I've got the square root of, that's 8 over 5 squared plus, all right, let's do this. I should have actually opened 2 brackets. So that's 8 over 5 that's squared plus, that's 1 over 5. Ooh, I'm dragging this so much. Oh, I forgot one set of parentheses. Okay, it says my parentheses are not balanced. Okay, what did I do incorrectly? Okay, but anyway, what I can do there is just simply say, all right, so we're going to have to do it from first principles, right? So 8 squared, that's 64 over 25. That will give us 1 over 25. So we can add those together. So that's square root of 65. So you can just simply add those two together. 65 over 25, right? Or you can just simply say, so that's the modulus of z, right? Square root of 65 divided by 5. Okay, right. Of course, I'm quite certain you can just try to simplify that as much as possible, right? So for the argument, what are we going to have, right? That's the arctan of x, right? That's 8 over 5. Y over x. So that's going to be 1 over 5 divided by 8 over 5. So that's y over x. So we can take that. That's 1 over 5 divided by 8 over 5. All right, and ladies and gents, we get that to be 7.1. Okay, I'm going to leave it as that, so that's 7.1 degrees, and that's how we will get that argument. All right, ladies and gents, that is truly how the cookie crumbles. I hope that you were able to follow on in those exercises. We will be going on to the next section where we are now looking at representing, whether it is a graph into a modulus argument form, and also the other way around. For me, for now, I'll see you guys next time. Sharp, sharp.